is Shanti Pless. And Shanti, you can start sharing your screen. Shanti is a senior research engineer at the National Renewable Energy Laboratory. And you lead a portfolio of projects oriented towards industrialized construction and its benefits in terms of sustainability and circularity. So we continue with the theme, and looking forward to hearing you. And I can see the screen too, so we can both hear and see. So please go ahead.
Great. Thanks for having me. Let's see. So yeah, I'm an energy efficiency researcher at NREL, and so have been there 20 years or so, focused on commercial building, multifamily energy efficiency strategies. And so I come at this from a different sector than the say the industrialized construction industry, but have done a lot of research on integrated design, how decisions are made, and to try to address all the challenges we have to get energy efficiency more cost effectively integrated into our buildings. And so over the last 2 years, we've built up a team at NREL focused on industrialized construction innovation, but for the specific purpose of trying to integrate energy efficiency strategies, distributed energy solutions, using advanced manufacturing concepts, construction innovation that we've been talking about, and process optimization, and to increase the productivity of, in particular, all the challenges we have in energy efficiency in buildings. So a quick overview of my full team here, plus a handful of other researchers at NREL. We're in a group called the Communities and Urban Sciences Research Group. And so we think about advanced building construction and advanced building science, and combine those together to find synergies to accelerate how energy efficiency is incorporated into buildings. Lots of information about the kind of work we get to do on integrating energy efficiency into industrialized construction there. But it's, I will say it's a part of a larger Department of Energy, U.S. Department of Energy initiative called Advanced Building Construction. You can see their site there. The Buildings Technology Office at the Department of Energy has been focused on thinking about productivity and energy efficiency, both in new construction, modular, but also in renovation, deep retrofits, wall panel prefabrication, and such to really increase the productivity of deep energy retrofits and new construction. We'll talk a little bit about that as we go, but there's a greater program that DOE is currently building up to try and accelerate energy efficiency and productivity in buildings. So these are some common projects in the United States that have been built this past couple of years that are site-built net zero energy multifamily projects. One in Colorado, a couple in California, and there's more and more coming online now. And they, there we go. And so they incorporate these types of energy efficiency strategies. These are all things I spent the last 20 years doing research on, figuring out how they work, doing a lot of energy modeling on the energy performance of each of these types of strategies, whether it's the envelope or good windows, full mechanical integration, 100% LEDs, right? All electric heating systems and high efficiency appliances, and solar everywhere, right? So we're reaching net zero energy across a range of projects, and but still struggle with integration, still struggle with having expertise in the design, the modeling, and the installation, the labor to pull this off, and as the need for affordable multifamily becomes a critical component for our industry, adding all this in an efficient, unintegrated way just means more costs, right? And so, we've all been learning about and know about the benefits of modular to try and address those costs, right? In terms of quicker to build, and where you can get up to 95% of the total construction to be built in a modular factory. It's an emerging sector here in the United States. In 2017, when MBI was looking at this, and they had around 3% new construction, mostly in multifamily and the hotel sector. Of course, higher quality, and if you're good at it, you can do it cheaper, right? Especially with the labor differences and labor cost differences in a modular factory versus on site. But as we're learning, it doesn't necessarily, even with all those benefits, doesn't necessarily result in more efficient apartments, and so or hotels. In talking to one a large hotel chain in the US that has some good experience doing modular hotel rooms. As they start looking at their energy performance of the most recent modular hotels, realize they're not necessarily more energy efficient than all the other not site-built hotels they've built, right? And so starting to understand that there could be a great way to get more energy efficiency, more cost effectively. But to date, for the most part, the industry is not really taking advantage of the benefits of off-site modular industrialized construction to get more cost-effective efficiency. So as a researcher, we've spent the last 2 years thinking about this and trying to figure out why and how. And so as part of that, we were able to partner up with a series of volumetric modular factories and projects in the United States to understand a range of existing performance, where they're at, and where they would like to go, and how to do that. And so working with these, a subset of some of the factories, both wood and steel framed in the United States, that have projects that allow us to really understand how to get them to be towards net zero. And a fairly standard way to engage with these types of projects from a benchmarking, understanding what they do now, where their opportunities are, developing a series of energy efficiency recommendations that they can pilot on their factory line, using tools like a discrete event simulation, digital twins of their factory process to understand how to increase their productivity, how to integrate these efficiency strategies at scale in their factory, and with the goal of actually getting a project built to understand that we can get to more efficient modular multifamily and hotels. And so one thing that we have been spending a fair amount of time on, and as we kind of engage with these processes and designs, is that the opportunity for design for manufacturing and assembly, a buzzword we all hear in this industry, but specifically around the energy efficiency strategies we'd like to see. And so what that means is that we're trying to find those efficiency strategies that allow us to be installed and integrated into the factory versus site installed scope, right? So a lot of these projects still are doing mechanical systems or centralized domestic hot water systems, and are not taking advantage of offsite construction. And so where we can redo the design so that these modular solutions apply to majority of the energy using systems, we can have some hope of maximizing that cost-effective energy efficiency strategy by leveraging these industrial engineering and manufacturing approaches. And some detailed list of energy efficiency strategies that we have been focused on, and what that looks like for those of you that get into the details of different energy using components in a modular apartment. The idea here is that if you can compartmentalize or modularize each of these systems so that it can be self-contained and therefore installed as part of the modular offsite construction process, you can significantly reduce the cost of the site installation that comes along with a lot of these systems that have an option to be centralized and not modular, or if designed upfront and integrated as part of the base modular solution, can be part of the modular solution that allows us to get more cost-effective integration, right? From in-unit ERVs, instead of centralized hot water, distributing a hot water system to each unit, which is takes a significant integration challenge to do that. Of course, all electric heating and air conditioning systems that are in unit as well. The industry in the United States, at least, isn't there just yet, so it takes some laboratory work and piloting and proving out of that idea. A lot of these apartments are putting in smart apartment controls, and it takes a lot of integration to pull off integrated controls that normally are site installed, that where we have an opportunity to reduce those integration costs. And on the envelope, ways to get the exterior insulation necessary integrated into that's typically a site installed scope into the factory through various strategies here we'll talk about in a minute, and of course air tightness as well. So on the left there, number one, right, you see a site installed mechanical equipment. That's all rooftop equipment that has to be site installed with refrigerant lines and power to provide heat and cooling to each unit versus a in-unit version of that, right? Pretty simple idea. Glad to be able to point out some of the great work that's happened overseas we've learned about around the cost and performance savings that we've seen in utility cupboards, as they call them in the UK. A great demonstration project by Skanska from a few years back, where they're building utility cupboards that were 44% cheaper instead of 42 hours per first on-site. They were able to do in 18. So they've demonstrated it. We haven't gotten there in the United States just yet. So part of what we're trying to do is understand how to bring what we know should work to US projects and factories. As a researcher and as with a laboratory where we can pilot and prototype some of these strategies, this is a prototype we have under construction right now in one of our labs at NREL to prove out this idea of an integrated mechanical room or prefabricated mechanical pod that has all the mechanical equipment from the ERV, heat pump hot water heater, the mini split, the heating and cooling system, as well as some of the electrical equipment, all integrated in a prefabricated utility cupboard or closet, right? And so the idea being that this can be prefabricated offline, just like the bathroom pod industry does, but for the mechanical pod. So it takes some prototyping and in a creative integration to pull this off, and so we're attempting to prove that out in a laboratory setting at the moment at NREL. Another great advanced manufacturing tool we get to use and have been working towards is modeling the process of how these modular units go together so that we can propose improvements specifically around some of the energy efficiency strategies we'd like to see. And when you want a factory to do something different, the question down there at the bottom, right, is how much time and money will result in that change, right? And it's really difficult to try these things in the middle of a operating factory that has certain throughput they have to meet, right? And so so by modeling all this, we've been able to propose time and performance savings potentially before we go actually and try it, right? And so there's a range of tools in terms of collecting information on the existing processes and how they build their modular units through machine learning time and motion data collection to visualizations and discrete event simulations. And so we use those tools to answer those types of questions. And then the first one we're interested in is if we could use an insulated stud like this that gets you the R value in your wall systems without having to do the continuous exterior insulation. If those studs cost more, is it worth it? If those studs require additional different types of framing approaches in the factory, is it worth it, right? And so we can model that process using those tools and quantify the labor savings, quantify the material savings, and then quantify the overall cost of a typical exterior insulation system versus an integrated insulation within a system that might be more expensive in material cost up front per stud, but can significantly reduce the overall labor because of eliminating a site scope of an exterior wall insulation system, right? In this case, showing a significant time and cost savings to do so, right? Kind of make the case for better insulated wall studs.
And Shanti, I'm just gonna give you a heads up that your time is about to be up. So
sounds good.
So wrapping up.
Yep. Last strategy here that we've been able to prove out. Aero barrier is a air sealing system where they spray an aerosolized sealant inside during a pressurized building pressurization so they can seal up all the cracks. They've got lots of experience doing this in on-site construction. This is the first time they've done it on a factory line. And so what we were interested in is how much time could we save by creating a manufacturing station to do this rather than having to roll this cart around to each apartment and do this one-off. And so up to 60% time savings and being able to have a standardized repeatable way for air sealing. Yeah, some of that data there. Okay, and so last slide for more information. Thanks for the time. A great paper that we just published on some of those strategies for more information. And again, look for more Department of Energy funding opportunities that are really trying to catalyze this industry, accelerate this industry around energy efficiency, renewable energy integration, and even circular economy concepts around advanced building construction, as we call it. So thanks for the time.
Thank you, Shanti.